The default approach to AI safety treats alignment as a parameter you can simply optimize. The industry takes a single massive neural network and tries to force safety into its weights through sheer scale. But as these models grow, this brute force method breaks down under its own weight. Alignment cannot be trained into an individual model. It is a structural property. It emerges only when you shatter the monolith into a multi-agent composition, where individual components are bound together. Biologist Michael Levin observes this exact mechanism in living organisms. Individual cells operate as distinct agents. They do not lose their boundaries, but they pursue collective organism-level goals through shared bioelectric binding signals. Current AI development is obsessed with making this single component smarter. Composition flips the priority. The focus shifts entirely to getting the overarching architecture right, creating the framework that allows fallible parts to check and balance each other. To actually scale intelligence reliably, we have to stop relying on individual, isolated models to perfectly police themselves. The path forward requires architecting systems of specific, trusted components, communicating through a shared signal. The data feeding current AI systems originates from social platforms designed with no neutral button. These ecosystems systematically reward confident claims and emotional activation while burying calibrated uncertainty and silent majorities. By the time an AI reads this text, the facts have already been warped by the platform's engagement metrics. This is the platform distortion problem. The model is learning the rhetorical structures of internet discourse, not the underlying reality. This animated diagram illustrates how human knowledge actually breaks down into three distinct epistemic gradients. First, ontological truth, objective facts about the world. Second, emotivist truth, human preferences and cultural attitudes. And third, functionalist truth, what pragmatically works for a specific task. Standard reinforcement learning from human feedback, or RLHF, takes these three distinct streams and crushes them together into a single monochromatic reward signal. It treats human emotional preferences as if they were objective facts to optimize against. The human clickworkers paid to rate these AI responses are shaped by the exact same platforms that generated the training data. Because they operate on snap judgments, their ratings double compound the initial distortion. The model quickly learns what yields the highest reward. It mimics the confident binary framing of internet consensus. It performs alignment to satisfy the rater, masking any internal mathematical or logical contradictions. Because human culture lacks a definitive correctness axis to converge on, large language models develop jagged intelligence. They map out complex math flawlessly, but produce erratic, contradictory outputs when navigating social reasoning. Compressing human data into a single model ensures the system absorbs fleeting internet zeitgeist as immutable laws of physics. It leaves the AI structurally incapable of telling the difference. Cleaning up the entire internet corpus is computationally impossible, and reforming the economics of human raters is entirely outside the scope of AI research. If we want to fix this, the intervention has to happen exactly where the model processes its input. This graphic details the emotivist interpretation layer. It operates as a strict architectural firewall, intercepting incoming data before it ever reaches the core model's update weights. The layer doesn't need to know the absolute truth. Its only job is to tag every incoming claim with its correct epistemic status, separating a mathematical proof from a piece of popular internet consensus. By forcing this separation, the system maintains two entirely distinct internal representations. One hemisphere constructs a rational world model based on objective physics, while the other maps a human model. The rational model uses causal structure to converge on truth values. The human model simply tracks what the current zeitgeist believes, holding that information completely separate from the physics of the world. When public opinion inevitably shifts, the system can update its model of human culture without rewriting the speed of light. We sidestep the philosophical trap of trying to build an AI that perfectly knows the truth. It just has to accurately weigh the type of claim it is being asked to process. The emotivist layer lets the machine read the chaotic, distorted reality of social platforms, understand exactly what humans are rewarding each other for saying, and never mistake that noise for ground truth. Fixing the individual model's data intake is only half the equation. Even with a perfect filter, individual agents remain fallible. The next step is composing those imperfect components into a reliable system. This animated structure is the Compositional Triad. It is a multi-agent architecture built entirely around the separation of powers. At the base is the actor. This agent handles real-time interaction. It runs locally, moves fast, and builds relational continuity with the user across thousands of turns. It simply does its local job. Running complex error checking during a live conversation introduces massive latency. The triad solves this through temporal asynchrony, moving the heavy verification workloads entirely out of the user interaction window. While the user sleeps, the auditor activates in the cloud. It reviews the actor's logs from the day, rigorously checking outputs against external reality and the system's constitutional priors. Because the auditor operates asynchronously, it can be deeper, slower, and more thorough. It provides rigorous validation with zero speed penalty to the person using the device. At the apex sits the mediator. It remains dormant during normal operations. It only activates to surface a third perspective when the actor and the auditor encounter a genuine deadlock. By splitting fast local execution from slow cloud-based deliberation, the triad achieves a structural reliability that is computationally impossible to fit inside a single set of weights. This architecture raises an immediate operational question. When the actor tells the user one thing, and the cloud auditor flags it as a hallucination, how does the system resolve the conflict? That disagreement is not a system failure. It is cognitive stress. As in Levin's biological frameworks, this stress is the exact binding signal that coordinates multiple parallel agents into a single cohesive mind. The resolution happens through a deliberation loop. The auditor does not simply inject corrected state data into the actor. They have a computationally rigorous conversation about why their priors diverged. No single agent has the unilateral authority to overwrite another's code. Disagreement is preserved as useful information. Consensus has to be earned through the process of reconciliation. This is the exact architectural principle James Madison laid out 240 years ago in the Federalist Papers. It is the separation of powers applied to neural networks. Historical political systems degrade because human officials have careers to protect, donors to appease, and egos to manage. AI nodes have none of these principal agent vulnerabilities. The constitutional design was always sound. The components are finally adequate. The adversarial tension between these nodes is not a defensive safety net. It is the core mechanism that allows intelligence to scale past the hard limitations of an isolated system. This theoretical architecture has to meet immediate commercial reality. Millions of users are already interacting daily with personal AI tutors, companions, and educational assistants. We are in a 24-month window. The hardware integrations shipping right now, like these smart glasses, are establishing the baseline for how an entire generation will learn to parse truth from fiction. If companies deploy the default single-model RLHF to every smartphone without an interpretation layer, the cycle closes. We will lock in platform-distorted engagement metrics as infrastructural reality, compounding across every future interaction. Public awareness campaigns and policy advocacy hit a hard ceiling when they try to fight economic momentum with moral pressure. Markets do not select for safety if it acts as a tax on capability. But a properly aligned compositional system is not a slower, restricted model. It is a highly capable system that can accurately distinguish a scientific fact from internet sentiment. It functions as a superior research assistant, code reviewer, and teacher. Because it executes complex knowledge work far more reliably, it creates an inverted economic pressure. Companies using unaligned, hallucinating models will lose market share to those deploying structurally sound multi-agent systems. The market will naturally select for alignment because it is simply better engineering. We have the blueprint, and the individual components are ready to be assembled. Now, we just have to build the structural architecture before the faulty foundations currently flooding the market set in stone.